Right. Okay. Hawking and Hartle said that the universe. Let's Google it, because apparently you guys don't believe me. Hawking
I'll
and
put it in the
Hartle
text
said the
chat,
universe
Tony.
doesn't.
It's not about
Hawking and
belief.
Hartle-
You
Hawking-
said maybe
Hartle-
Hawking misspoke. Maybe
Okay,
you don't know what Hawking said, PhDTony. Can you concede? Can you please concede that you don't know what Hawking said? Can you please concede that you don't know what Hawking said?
And
Tony, chill, dude. I've put it in the text chat. You're right. Early on in his career, he talked about beginning. Later on, he's talking about exactly what you're talking about. What was it? Spherical something or other. Like Earth has no edge.
The Hartle-Hawking state proposal. The Hartle-Hawking state proposal.
That's it, with James Hartle in 1983. I've put it in the chat.
Yeah. Okay. So the entire you are misrepresenting Hawking's life work by suggesting, he suggested that it's a boundaryless universe in its initial state. Anyway, if we're just dogpiling with the misquotes and the misrepresentations.
You repeatedly said Hawking never said time as a beginning, and Hawking did say that. So can you admit that you didn't know that he said that?
No, sir.
Yeah, but okay.
I didn't say. No,
to
I need to respond.
To be fair, Tony is right in the sense that he apparently changed his position later in his career. We don't need you to respond and say it again. It's very tiresome. It doesn't really matter, because I invoked the later work, which was 88, and I quoted it verbatim, which is that the second law states that disorder always increases with time. Like the argument about human progress, it indicates that there must have been a beginning. I only invoked the analogy.
It's tiresome for me to repeat myself, but feel free to read the quote for the 20th fucking time.
No, I'm just making a point. I only invoked the analogy. Okay, I did not say, hey, let's debate about the quote again. Someone asked what the conversation was about. I gave a quick recap, and then I just used the analogy of human progression, which absolutely is not misrepresenting what he said. That is the reason he invoked human progression as the analogy. So we can take that out, because my point is simple. The second law, saying that entropy increases, the amount of usable energy decreases. For it to decrease, it must decrease from a beginning point, just like human progression. If humans are progressing, we must have started somewhere to progress from.
Yeah, and
was there time before the Big Bang?
That's an idiotic statement too, because even the concept of the start of humanity is not a very well defined or scientifically meaningful concept. But the position remains that Hawking in the work that you are quoting lays out the boundaryless universe hypothesis and says that time does not have a starting point. You are putting a lot of weight on his use of the term beginning, when what he meant to say was that the second law of thermodynamics requires that the universe has only been in existence for a finite amount of time. But finite and bounded are different things.
Finite amount of time necessitates a beginning, but what's an
No,
ending?
it doesn't, sir.
What's the opposite of finite?
The opposite of finite is infinite, but something can be finite but not bounded.
No. But if something is
the surface of the sphere.
Yes, I know.
The surface of the sphere is finite but not
saying the
bounded.
sphere thing, man. Okay, so if there is a
Well,
finite,
apparently you don't understand it, so I don't know what to do.
Stop, man. Yeah, the fact that you reify time and then use a physical object of a sphere for a super poor, desperate grasping at straws analogy doesn't mean anything to me. I want you to answer this question: what does the phrase "finite amount of time" mean?
It means that, so we measure time in units. It means that there are a finite number of units from now back to the beginning of the universe.
Oh, the beginning. Okay,
yes.
Cool. So, he didn't misspeak, and you're actually kind of conflating a bit of an equivocation, right? You're cutting out a lot, bro. But like you're kind of equivocating because you keep saying like time. Like in the context of this quote, he's saying universe, right? But it doesn't really matter, bro. It's just the point is simple. Does everyone acknowledge
the universe is space-time, right?
Does everyone acknowledge? No, space-time's stupid. But does everyone acknowledge that if the amount of usable energy in the universe, let's just say, okay, hypothetical preface there for you, if the amount of usable energy in the universe is decreasing, that would mean that it's decreasing from a starting point.
No.
Okay, so it could just, if we rewound the clock, it could just go on infinitely forever.
Sorry, you need to define initial point better.
Well, like just if there is no starting point, then the word decrease has no meaning. If there is no starting amount,
relativists would say that the word energy has no meaning. So I mean, or is at least very difficult to, or is at least very difficult to define in relativistic terms. But or very very difficult to meaningfully define in relativistic terms. But you can again, I'm not sure how to respond to unscientifically formulated questions. You are suggesting you are basically trying to say, does everybody agree there's a beginning point? You're just trying to word it differently.
No. I'm actually asking a very specific question. If the total amount, so if the amount of usable energy is decreasing, then there must have been an initial amount to decrease from, or the word decrease would have no meaning.
Okay, but again, you're making the mistake of applying this to the universe as a whole. Again, because the universe is expanding and
you cut out.
We know that we know that the amount of energy in the universe is increasing. So to claim that usable energy must be decreasing on a universal scale, I don't know that that's true.
Okay, so that's a different. So then you should have just been intellectually honest and said, yes, if the amount of usable energy is decreasing, then that would mean that it had a starting point to decrease from. And then your argument is, but I think it's possible that the second law of thermodynamics doesn't apply to the universe.
Yeah.
You agreed to that, Witsit.
So
you said,
there you go.
You said it doesn't apply.
No, I didn't.
Witsit?
I said the first
I heard
law.
you.
I said, no, I didn't. When did I say that? My whole entire argument has been pointing out the absurdity of the position claiming the second law doesn't apply. And this is actually Hawking's whole point and Eddington's. That's Hawking's whole point and Eddington's whole point, right? Where he says the argument about whether or not the universe. The argument about whether or not the universe.
Division fallacy.
The argument about whether or not no, it's not. The argument about whether or not the universe had a beginning persisted into the 19th and 20th centuries. It was conducted mainly on the basis of theology and philosophy, with little consideration of observational evidence. This may have been reasonable, given the notoriously unreliable character of cosmological observations, until fairly recently. The cosmologist Sir Arthur Eddington once said, "Don't worry if your theory doesn't agree with the observations, because they're probably wrong. But if your theory disagrees with the second law of thermodynamics, it is in bad trouble. In fact, the theory that the universe has existed forever is in serious difficulty with the second law of thermodynamics. The second law states that disorder always increases with time, like the argument about human progress. It indicates that there must have been a beginning." And he actually paraphrased Eddington, because what he literally said is, if your theory is found to be against the second law of thermodynamics, I can give you no hope. There is nothing for your theory but to collapse into the deepest humiliation. What I'm saying is, I agree. I actually agree with them, right?
Conservation laws don't apply to the universe as a whole.
Nobody said conservation. I said entropy. We're not talking about the law of conservation of energy. We're talking about the second law of thermodynamics.
Yes, yeah, and the second law of thermodynamics applies to energy.
Yes, so I also gave papers that also said, not just Stephen Hawking's quote, bro.
Okay. What do your papers say, Taylor?
I already tagged you in them. I'll do it again.
But can you read off the part that specifically
If the
addresses the
universe
point?
increases in entropy and disorder with each bounce, this is invoking a Big Bang loop, which is what the gentleman referenced earlier, which is what we were talking about. If the universe increases in entropy and disorder with each bounce, the amount of usable energy available decreases each time.
Yep.
Does the second law apply to the universe as a whole, Taylor?
Which is the most popular, which, just so you guys know, that's the most
Yeah.
that's the most popular claim within like your realm of like the academic circles. The most popular claim to get out of this issue is this idea of an infinite loop.
That is a claim. That is one potential. I can't tell if am I
can hear you.
You're good.
Yeah, we can hear
Okay.
you.
Sorry, it sounded like Witsit got clipped. So I don't know if that was my internet or whatever.
He was clipped for me.
Okay, but this is one possible hypothesis, and as Taylor is correctly pointing out, there are many people who have very strong theoretical opposition to the Big Bounce hypothesis or the Big Crunch hypothesis, the Big Bang Big Crunch hypothesis. Very many serious cosmologists dismiss it, and Taylor's argument is a cogent one. However, it relies on continuity of time through various cycles of the event. Whereas there is a possibility, again, if you imagine time as spheroidal, that you'll end up back at your initial point. That it's not a matter of time going on infinitely, and there's big bounces and crunches. That you walk along the sphere and then you get back to your initial point. So in that hypothesis, we've had this conversation millions of times before. We'll have it millions of times again.
Yeah.
But there are bazillions of cosmological models, and none of the professional cosmologists look at the data, look at the theory, and come to Witsit's conclusions or Taylor's conclusions.
It's not true. The vast majority said there is a beginning. The vast majority say there is a beginning.
No,
but you're just appealing to the God of the gaps.
Yes, they do.
I'm not appealing to the God of the gaps. What I said was that if the first law of thermodynamics says matter and energy cannot be created nor destroyed, but the second law says the amount of usable energy is decreasing, that requires a beginning. So we can't claim it was always here, which means that there was a beginning. So now we have to invoke a creation. The antecedent to creation of energy and matter is a creator. If it doesn't, it's not confined to the current laws of nature, then that means it's supernatural by definition. So we don't have a supernatural creator.
That's affirming the consequent.
That is a pathetically.
It's not affirming the consequent.
Yes,
that is a pathetically infantile Gish Gallop.
And I can prove it.
Most of those were just
nonsense. You don't know. So for starters, we don't know that matter and energy were created. We don't know that matter and energy were introduced. We don't know where matter and energy came from. We don't.
Wait, you're saying we don't know if they were introduced?
We don't. So sorry. I'm sorry that I was still speaking when you chose to interrupt. There is a bunch of stuff about the early universe that we don't know. We do not know that matter and energy was created. That's just an assertion on your part.
You're saying that we don't know if matter and energy was introduced, but simultaneously for an hour have argued that there was a moment that there was no matter or energy. So how do we get from...
No, I've never argued that.
How do we get from
false dichotomy with it? You gave a false dichotomy.
I'm going to try to finish speaking. Thank you. How do we get from there is no matter and energy to there is matter and energy without it being introduced?
I can explain that.
At all points in time. So what you're saying is that there is a point in time at which there was no matter and energy. And I dispute that there existed a point in time at which that was true. Because by definition, in order for time to exist, the universe must exist. Space-time must exist. So there is no point in time at which there was no matter and energy.
Okay, so
it'd
to
be
quote
called
you,
the second law.
in order for the universe to exist, space and time must exist, matter and energy must exist. Therefore, when you were earlier claiming a situation or scenario that did not have matter, did not have energy, did not have space, did not have time, you were invoking a time prior to the existence of the universe.
No. The very concept of a time prior to the universe is incoherent.
Dude, that's what the Stephen
Then lay out
Hawking
your
quote
model,
says.
bro. Lay
It's
it
all
out.
recorded, dude. I need clippers. I just need clippers
That's
to
what-
take this stuff and show what he argued for an hour, and then watch how he just denied
No,
the necessary implications of what he argued.
you've just
Well, you're not going to
misunderstood.
gaslight me, bro. So good. We'll try it on someone else.
Tell us your conception of how it began.
So your confidence that you correctly understood what I said is absurd, given your.
Do you want to bet $1,000 on it?
That I said that there was a time before the universe?
No, good try there. That you specifically tried to defend a scenario where there was no matter and there was no energy. Good. Yeah.
Yes, he did.
Okay, and you just said that, and that you just said that a universe cannot. First of all, the idea that space and time exist without matter is incoherent. And then you said that if space, time, matter, and energy don't exist, then the universe doesn't exist.
Well, as we understand it, yeah, that's true.
Okay, so then the nesting implication of all of that put together.
But the possibility remains that the universe existed just in a form that was different from the way we perceive it now.
So now you're contradicting yourself, because just a second ago.
It depends what you mean by universe, right?
Well, you just said that if there was no matter and energy, there could be no universe. And now you were saying there's a.
I'm talking about the universe that we can perceive now. There is and how that universe came to be, the process by which it emerged, by which time came to exist, is fully described by Hawking, right? Hawking, in his boundaryless universe hypothesis, talks about the differentiation of time from the other axes, and the process by which it becomes time as we currently understand it. But before that, so the process by which that occurred is a mathematically complex one by which it peels off from the space dimensions.
This is a perfect example of, like, underneath the disguise of ostensible certainty is just paradoxical doublespeak, right? Because once we really got down to it after all this time, you say that, dude, this is so incoherent. You can't have space and time without matter, and without space, time, matter, and energy, you don't have a universe. You can't have a universe without that. And I said, oh, okay, so earlier when you were invoking a scenario without space, time, matter, and energy, then you were invoking a time prior to the universe, because you just said the universe can't exist without those things. And then you said no, right? It's just doublespeak. It's fundamentally doublespeak.
There was nothing before the universe.
Nothing?
Yeah.
Oh.
I mean, the concept of nothing itself is incoherent, because nothing is a thing.
I don't mean that nothing. I mean the other nothing.
The other one.
Right.
All right.
But the in discussing, so time, as we understand it, we're talking about what we consider to be the real axis, of time, and that progresses. But if there's an imaginary axis of time, then in that case, the concept of time becomes I forget the term. It's got multiple meanings. So, stuff can happen on the imaginary axis of time without happening on the real axis of time.
I was just gonna say it's polysemous. That's the word you're looking for.
Oh, polysemous, yes. That's the So time becomes, and this makes your arguments extremely fraught with casual wordplay, right? The very concept of time, given that we talk about time having a real value that increases, but the possibility that time is an imaginary or indeed a quaternary or an octonian, quaternion or octonian entity, raises possibilities for things to unfurl, for events to occur, and without progression along the real time axis that we are familiar with.
Okay, and I don't think most people probably ever heard of this, right? And I'm only like kind of vaguely familiar with it, but like imaginary time, okay, is the idea that Stephen Hawking used to just like as his get out of jail card, basically. I mean, it's not intelligible, it has no evidence whatsoever. Like, admittedly, we've never observed such a thing at all whatsoever. It's an attempted abstract, right? But it's not even coherent. It's the idea. It's the idea that at the beginning, near the beginning of the universe, time behaved more like a spatial dimension. That's what I remember.
Imaginary. Witsit, they mean imaginary as in algebra. That imaginary.
I know what it means. It's me just now describing it with specificity. Try to keep up.
The fact that integral transforms provide meaningful results when applied to physical systems. In an integral transform, you take the equations governing the system, you convert them into the complex plane. You do where things become simpler. You do a bunch of manipulations there, and then you convert them back. The fact that gives accurate, physically robust solutions suggests, and in that you've transferred into frequency space, which has an imaginary component. If frequency has an imaginary component, time has an imaginary component. It's not. It is outside of our everyday experience, certainly. But to say that it is untrue just because it's outside our everyday experience is again a faulty.
So this isn't magic, right? This isn't magic, guys. Okay, that taking real time t, changing it to it imaginary time, so that the math works out a little better, and then literally claiming an imaginary unit, reifying that mathematical trick that simplifies equations, and then jumping over and conflating that somehow to physical reality that doesn't exist now but once did. That's not magic. Imaginary units of time isn't magic. And sure, that's not observable in our physical reality, and we don't have any evidence for it and can't even really make sense of it and have literally no leg to stand on whatsoever that it exists. But we can claim it does, and then we can reify time twice, once it being abstract conceptual quantification of passing and motion in and of itself. And then we can take that quote unquote real time, which is a reification fallacy, transfer it over to an imaginary time, which is a double reification fallacy, where it's just a mathematical imaginary unit. And I just want to point out its absurdity. It's like such a double standard in this conversation that
what he said is absurd.
He's going.
Dude, it's an absurdity. Can I finish my point? Finish my point? It is blatantly a double standard, and it shows how bad faith and disingenuous the other side of this conversation is. Where you will portray yourself with this ostensible confidence, right? That the imaginary, Brenda, I'm gonna kick you. We don't need your little cheerleading derogatory comments from the sideline.
Shut up with it and don't moderate your own conversations. It's
Brenda doesn't get to just scream "uh-oh" through the middle of someone. It's literally just like a little child.
Keep going. Keep going.
Then mute them while you're talking.
Okay.
Yeah, I got muted for that shit.
Okay, it's like very simple, right? It's blatantly a double standard, right? Where, you like when I'm saying, oh, look, okay, well, if we are having to invoke something attributed to a force that's not limited to the laws of nature, then that's supernatural by definition. And if the matter and energy was created, then the antecedent of created is a creator. So now we have a supernatural creator. That satisfies the issues that we have to explain the existence of the matter and energy in the universe, right? That's magic. But if we say, maybe near the beginning of time, there was a moment that time wasn't like time. It was like an imaginary version of itself where it doesn't match reality at all as we know it. And we have no evidence at all that that could exist. And I can't fully explain to you exactly what that means because it's just a mathematical concept used for equations to become simpler. If I pretend that that actually was a real thing that existed once but no longer does, and I have no observational evidence whatsoever, then that is permissible, even called science, and isn't magic.
Are you done?
Yes.
That was just the longest personal incredulity.
What are you talking about? He just repeated back what you told him.
So let's do. This is a hypothesis. This is nobody is claiming that this is real. All they are saying is that it is plausible, possible. And this gives the lie to Witsit's claim earlier. Witsit's claim was that somebody who says I don't know has to substantiate the alternative possibility, and we saw it here. In order for it to be substantiated, it must be observed. That was his standard. We've got no observational evidence for it, therefore we're rejecting it. And so
he never said that.
I didn't say that.
Yes, he did. He just said
no, he did not.
We can't. Shut up, Taylor, while I'm talking. He just said we can't observe imaginary time. We can't observe. We don't observe this. We have no observations validating this. Therefore, it's magic. That's literally what he just fucking said. So don't tell me that he didn't say that, because that is what he just said.
That's not all I said.
And he said, yes, it is, Witsit. Again, we can clip it. We can go back to recording it. You just said there's no evidence for it. There's no observations for it. Therefore, you're rejecting it.
No, that's not true.
And this is
hey, bro, if I'm saying it's a straw man, why wouldn't you let me
shut
clarify?
up while I'm talking.
Tony, why not let me clarify this?
It's an accurate assessment. It's an accurate. It's an accurate summary of what you just said.
Can you just take a breath and just assume that I'm operating in good faith right now?
You said there's no evidence. You said there's no evidence. You said it multiple times. You said there's no evidence. It's not observable. And therefore we're rejecting it. That's exactly what you fucking said, and everybody in the chat can hear it. And I don't know what conversation Taylor was listening to.
You're missing an important part. So if you would just pause for a second.
We don't have any observations, therefore we reject it. And this is the lie behind his rejection of agnosticism.
Pause for a second.
I don't see why you got to carry on for fucking 5 minutes.
No, I'm going to give the mic back to you. My whole intention was to clarify that isn't all that I said. So then you could actually maybe properly rebut my argument. So I'm actually trying to help you and save time here. I did not say it isn't observable, therefore it's magic. That is a straw man. What I said was that it was baseless. It is, and all I did was actually just re-say what you said, which is like, sure, it has no relation to our physical reality, and we can't understand it or observe it in our physical reality. And then I made the point that it was simply math, that you were then conflating to physical reality to even claim it was possible. So my actual argument was that it was mathematical, which is abstract, and it's a reification fallacy, and it's an imaginary unit that you can't even properly define. And then you basically assert it. And in addition to that, there is no empirical evidence.
This is supposed to be a clarification so that I could continue speaking. Can I speak now?
That's what it was. Yeah. Now, properly address what I said.
So again, well, let's ask a question. What does reification mean?
It's attributing physical properties to concepts. It's a misapplying
Yeah, okay.
concreteness to an
So
abstract.
if I propose a hypothesis, am I reifying anything?
Yeah, if your hypothesis is claiming that it's real within it, which is what you were doing.
A hypothesis doesn't make any claim that it's real. A hypothesis suggests that something is possible. That's
what I'm saying is if the premise baked in is assumed to be real to then propose the conclusion.
That's assumed in all hypotheses.
No. I'm saying
all hypotheses are based on an assumption.
No. The actual constituent parts are not assumptions. The assumption comes in when it comes to the assumption comes in with the cause and effect component, the actual relational component. Dude. Okay, so it's like saying it's like saying unicorns cause it to snow. Okay, if I'm just assuming that unicorns are real to then put forward the hypothesis that they cause it to snow, the hypothesis is that the unicorn is the cause of the snow, but I have just assumed that unicorns are real to even put forward the hypothesis. So a reification fallacy is also called a concreteness fallacy. It's misplaced concreteness to something that is abstract, and that's exactly what you did.
Sir, no, it isn't what I did, sir. Nobody is saying that this is necessarily true.
I didn't say you said that, bro.
What people are saying, and again, so what you're asserting, sir, is that you are in a better position to whether or not this is a valid hypothesis or not. Did Hawking and Hartle publish scientific papers on this topic?
Within Hawking, yes. Within Hawking's work, he invokes imaginary time.
Yes. In Hawking's work, he invokes imaginary time. So a professional scientist put forward a hypothesis. Other professional scientists see what he is doing, and they accept that it is a hypothesis. They accept that it is not yet substantiated. They accept that it is not yet observed. It remains hypothetical. Nobody is claiming that it is real. Nobody is claiming that there is observational validation for it. It is a hypothetical. There is no reification in hypothesizing.
Okay, brother, to even hypothesize, thus claim it is theoretically possible, means that it has to be logically viable, and to claim that a mathematical construct that can't even be properly defined is real or physical is a reification fallacy.
Yes, and nobody is claiming that it is real. All anybody is claiming is that it is possible.
Okay, it is possible that it's real.
Yes.
Okay, that's not true though, because if it was real, it can't be real because it's a reification fallacy.
It makes quantum
circular.
How is it circular? Okay,
yes, that is absolutely circular.
Hey, man, listen. Is imaginary time strictly a mathematical concept?
We don't know.
Oh, okay.
So quantum calculation is more accurate.
At present, it is. At present, it is an entirely mathematical concept with no observational validity. Though there is, very strong theoretical foundations for it. A lot of practical problems in quantum theory and in relativity rely on treating things in the complex realm.
Yeah, but this is kind of my
usable real world.
Hang on, mate. I'm not finished. So we have a theory. We do theory involving complex time. We compare it to real world observations. We got the right answer. We correctly predicted the behavior of the system using imaginary time. So
do you know how?
So imaginary time is not contradicted by the observations. So it remains a plausible hypothesis. Until it is contradicted by the observations, it remains a possible explanation.
And just for the room to know why that ever did occur, and by the way, it doesn't always occur. Typically, it doesn't. Just not like it just consistently gives us the right answer, but it does help them a lot with all their mathematical issues. But the reason that it helps is because it's treated as a spatial dimension. What do you know? Once again, once they start to acknowledge the substantive quality of a background medium, they're able to actually match observation. But my point was not even strictly that it not only has never been observed, it was also that it can't even be properly defined or proposed coherently. And further, it is a mathematical concept, right? Imaginary numbers, imaginary units. It's like me saying that the imaginary numbers are what fuels my car. And well, right now we don't know that to be true, but it's possible. No, it's never possible that the imaginary numbers fuel my car because they're just mathematical concepts. They are intrinsically abstract. They cannot have concreteness.
So that's just an assertion on that is a series of assertions on your side, on your part. So you're claiming that there can never be any observational evidence. You don't know that. You claim that your stupid analogy about cars. We know what fuels cars, and we can tell that it is in imaginary numbers. So the observations contradict that. As soon as we have observational data that contradicts imaginary time, fine. You've made your point. But until that happens, this remains a valid hypothesis. It has not been falsified. The claim that it has, and again, the central point here. Back to your central point. You claim that it is poorly defined. A bunch of professional mathematicians and physicists disagree with you. You claim that it is incoherent. A bunch of professional scientists and mathematicians disagree with you. So you're just asserting that you know better than the scientific community. And again, the amount of delusional confidence you must have in order to make that argument is off the charts.
See, that's actually not true. Okay. And so I just want to make sure that the room starts to notice this pattern, right? Because he's has a PhD. He says these things as if we must, as if it should just be believed, right? And one may be convinced because he has a PhD where he speaks on behalf of the quote unquote scientific community. Actually, the popularly held position is that it's just a placeholder. It is not a popularly held position that it is, in fact, a real thing. The popularly held position is it is a placeholder. So it's actually much more popular within the quote unquote the scientism circles, that it isn't actually the answer. It is just a mathematical placeholder. It is used quite a bit. It helps them fix some of their issues. But this is my issue. See if you can just.
I want to respond to your straw man before you move on to another. I never said it was popular. I never said it was accurate. All I said was it has not yet been falsified.
No, you said tons of mathematicians.
And the scientific community agree with me that it hasn't been falsified.
No, what you said was that in terms of it being properly defined and coherent as a hypothesis, tons of mathematicians and tons of physicists disagree with me. That isn't true. Like
provide one. Okay, provide me a scientific paper that argues that Hawking's work is mathematically incoherent and poorly defined.
Oh, you shifted the goalpost there because no one's disputing the mathematical viability. You're not addressing the actual argument. And so let's see if we can do it this way. You asked me, and I'm going to ask you, what is a reification fallacy?
A reification fallacy is when you assume a theoretical construct is real, a construct for which you have no observational evidence is actually real. You assert that it is real without observational validation. That is a reification fallacy. And it most commonly occurs because you've got a model that works, therefore you assume that the model is reality. And that's not scientific.
Okay. Now, all that extra stuff isn't actually what a reification fallacy is, right? It's just when concreteness is improperly applied to an abstract. Now, the issue is that, well, let me just ask you, is math abstract?
Yes.
Okay. So when people treat the mathematical concepts that are abstract as if they can have physical, actual properties or as if they're real, by definition, that would be applying concreteness to an abstract.
Show me somebody who does that.
Anyone that's claiming that in actual physical reality, at the beginning of the universe, something called imaginary time existed and did things in physical reality.
All they're suggesting is that it might have existed. They're not asserting that it did.
Okay, but for it to might have existed would mean that it could have concreteness, which would mean it's a reification fallacy.
No, so that is again a circular argument. You're asserting that it can't have. You're asserting that it can't have concreteness, and you don't know that.
But wait, you acknowledge that math was abstract.
Yes, I acknowledge that math is abstract, certainly.
Or imaginary numbers math.
And every scientist understands that all models are wrong. Some models are useful, right?
Our imaginary numbers are imaginary.
Nobody is claiming on the basis that just because a model works that it must therefore describe reality.
Our imaginary numbers. Our imaginary numbers math.
Yes.
Okay. Our imaginary units math.
Yes.
Okay. And is math abstract?
Yes.
Okay. So if we apply concreteness to imaginary units, that would be a reification fallacy, right?
No.
Oh my God. Okay.
This is that Patrick meme with the wallet. Have you guys seen that?
So again, while I appreciate your attempt to.
Military's birthday thing last night. And flip off, I don't know.
Rocky, I'm gonna move you to hot mic, bro.
Is Rocky a hot mic?
I moved him.
Okay, so the whether or not something, do you agree that mathematical tools can be used to accurately model physical systems?
Rakia, you jumped back in here and started hot micing again?
No, I turned it off. Sorry.
It's okay. I'm like, dude, that's good. To model reality, sure, or to just to describe reality, yeah, math can be used to describe reality.
Accurately describe physical systems.
Yeah.
Okay, so if we agree on that, do you agree that it is possible that time has a component orthogonal to that we can see?
No.
Why not?
Because, description of reality is not synonymous with a primary constituent component of reality. Those are fundamentally different.
So you're claiming to know that doesn't exist. On what basis are you claiming to know that there is no component of time orthogonal to that which we can perceive?
Well, I just explained it because math is.
You need observational evidence, sir. Conceptual arguments aren't going to help you with this. You need observational evidence precluding the possibility, and you don't have any.
This is shifting the burden of proof. I'm challenging or denying the claim. I don't have the burden, I'm articulating with specificity why I'm challenging and denying it, which is math is fundamentally abstract. It cannot have concreteness.
But we're not talking about mathematics. We're talking about the nature of time.
You said it was imaginary.
I'm not talking about imaginary. I'm talking about a component of time orthogonal to that which we can perceive.
That's just super vague, right?
But it's you're asserting that it doesn't exist. I want to know on what basis you're making that assertion.
Well, because time is an abstraction, and when you're saying orthogonal to
No,
what
it
we can
isn't, sir.
perceive,
Time is not an abstraction.
well, it is when it comes to the actual conceptual quantification of passing. So I would say progression is in and of itself a thing, but you are trying kind of sleight of hand to say it's synonymous with the quantification itself, which is why I'm pushing back, right? Because no, the quantification can be used to describe, say, passing, right? But this is, and you understand this, I'm pretty sure, right? You said, can math be used to model and describe reality?
We need to talk. What is the physical definition of time?
I'm not going to agree with any.
Don't use this vagary passing bullshit as though it's meaningful. You talked about sort of poorly defined terms and incoherent stuff. Define time. What is the physical definition of time?
I wouldn't attribute physicality to that which is metaphysical. That would be ignorant.
The definition of time in the field of study known as physics.
It's a mathematical construct of dimension of.
No, it isn't, sir.
What do you mean? No, it isn't.
Time in physics.
So you're asking me because it started by asking me what my definition of time is for me to define it, and now you're telling me
I want you to use the definition of time that science uses.
Which type of time? Newtonian time, relativistic time?
Doesn't matter.
It does matter. They're fundamentally different. In Newtonian physics, time is absolute, and in Einstein, it's relative.
Okay. None of that matters for the definition of time.
well, why not? What?
Because time is defined operationally.
Dude, you're asking me, just to clarify, you're asking me to give you the mainstream pseudoscience definition of time?
And mainstream is not pseudoscience, by definition.
That's not by definition.
Yes, by definition.
Only if you use an appeal to majority fallacy.
No, only if so you're
Dude, okay, what are you looking for here?
Scientific results are based on logical conclusions from observational evidence. I understand that you reject that as a basis on which to investigate subjects like the shape of the Earth. But if we're going to have a meaningful conversation about what time is, we need to be using words in the same sense.
I agree with that.
If you're using some weird or bizarre definition of time, which is different from what science uses, mainstream science, then we can't have a constructive conversation.
Okay, so listen, man. I was in good faith actually using time as you use it. And then that's why I then clarified, although I don't agree with that, right? So if you were listening to me, you would have paid attention to actually, I just began the interaction in good faith, yielding your use of the word time, right? But like, I don't know what you would be looking for other than like an interval of change, right? Like
time is what a clock reads.
That's not
time is what. Yes, that is the definition of time.
Cite it.
Okay, go to the Wikipedia page. Time in physics.
No, look. If I go to Google, I'm going to go to Google right here.
What about before a clock, though?
I'm going to go to Google.
Shouldn't we exist in a world before a clock? You can't describe time.
Atomic clocks existed before clocks. So the definition of clock is what you're missing there. The passage of time is also measured. Time is also measured by the passage of light. So how far light has traveled defines time.
Dude, I just looked it up. It literally says exactly what I said, Tony. Dude, it's like I just said define terms. I said define terms in terms of physics on LibreText, physics LibreText. Also at byjus.com. I don't know what that is. But anyway, I just said define term in terms of physics, and it says interval over which change occurs.
Okay. Look up the Wikipedia article, time in physics.
No, why, dude? Okay, you're saying time is what a clock reads. So when I'm giving a much more specific, substantive definition, you're correcting it with you're correcting.
You're giving a
I'm
cherry pick definition.
You're correct. You're
of-
correcting it.
We shouldn't be having an issue with that, dude. Come on, Tony.
You're correcting it with a definition that my 3-year-old would give.
I'm correcting you with the definition of how physicists use the word.
In physics, time is defined as a fundamental quantity representing the progression of events from the past to the present into the future, and its measurement is based on the.
Without a context, you're just reading.
Well, okay,
give your source before.
Why? That's not how it works.
I don't understand how this is so inimical to you to concede that the definition of time used in physics is what clocks measure.
Well, I'm not saying that isn't true in your paradigm. What I'm saying is that isn't the definition of time in your paradigm, because what a clock does is changes and moves, and it's quote unquote measuring intervals of that change or motion.
Not all clocks move.
Oh, but it's still. Does it change? Do all clocks change?
Define change.
Are you
in some senses, we use photons as clocks. Does the photon change? It changes position, but the photon itself.
Yep, it changes. Atomic clocks. Atomic clocks are quantifying change. Like every time you're going to try to invoke time, it's going to intrinsically incorporate change.
Yes, and what if there is no change? Does that mean that time has stopped existing?
No, it just wouldn't be a measurement of time in your paradigm.
Right, but so you're claiming that the concept of time is poorly defined. That's your main claim. So in which case, you don't. Everything. No. In which case, so that was your stated position is that the concept of time is poorly defined. Is that right?
Yeah.
Okay. All right. Well, every scientist on the planet disagrees with you. So
that's not true. I'm a scientist. I agree with you.
No, you're not. Okay.
Yes,
there are 3 qualifications by which you can assert that you're a scientist. Do you have any formal qualifications from an institution of withstanding? Do you hold any degrees from universities?
Whoa. Okay. So Nikola Tesla wasn't a scientist? That's crazy.
Second, do you have you published any results in that have made it into peer-reviewed literature in reputable journals? Have you done that?
No.
Have you individually had your findings assessed and learned by subject matter experts?
Yeah.
Okay, who?
Robert Bennett.
Robert Bennett. When did this occur?
Like millions of times, just chilling on Discord.
Okay, Robert Bennett confirms that you have made novel scientific discoveries, does he?
Well, now they need to be novel.
If I contact Robert Bennett, that's what he's going to say, is it?
Now it needs to be novel. Now, in order to be a scientist, you have to discover something brand new that no one else has ever seen.
Yes.
So how are you a scientist? Enlighten me.
Okay. How have I? Well, I've developed I've developed novel techniques for analyzing gravitational data from satellite missions. I developed, and it has allowed us to determine better models of mass change on Earth's surface. In particular, the loss of mass in the Caspian Sea and the loss of mass in the Antarctic ice sheet.
So you actually just applied it to a geographical region that hadn't had it previously applied to, but you didn't actually discover anything novel. So that's interesting. So look, this is all really stupid and pedantic.
That's not what I said, sir. I developed a novel technique. I developed a novel technique that nobody else had developed, and I applied that to data to achieve results that other people had not achieved.
So, Tony, you realize I was trolling you anyway. Although I would say, it's pretty simple, like exercising, the study of natural or physical science, or performing experiments. You can disagree in your world, your fragility of worldview is really like, I'm indifferent to it. I don't care that you really place a big importance on the mental conditioning that exists within universities. I would say Nikola Tesla was one of the best scientists ever, right? He didn't have a degree. So now he did discover many novel things, but this is all this is irrelevant. This is irrelevant. Let me just say, okay, I'm not a scientist if that can move the conversation forward. According to your parameters, I'm not a scientist. Although I think I've come up with some ideas that maybe some people haven't, and then I've had some people that would have all of these credentials that you claim are so important, acknowledge the possible validity of them or whatever, but I really don't care about any of that. So, can we just get back to the point, and this has gotten so far off the tracks here, which is that the idea of an imaginary unit, imaginary time, which is actually, just so the room understands, something Stephen Hawking put forward to avoid the inevitability of the beginning of the universe, thus a creator. In his own words, he explains that his obsession with this topic was all about finding a way to remove the need for a supernatural creator. The imaginary unit is used even to this day to fix a bunch of their problems. And the issue with it is it's claiming that near the beginning of the universe, although it allegedly didn't have a beginning, but to even propose it, they always invoke a beginning. Near the beginning of the universe, time was different. And how so? I don't really know, but we're going to call it imaginary time and then treat it as if it is a dimension, right? And then we're going to plug it into equations and then treat it as though it's real. So to hypothesize that time itself used to be imaginary time, even though I don't know what that means, and then give concreteness to the imaginary unit that represents it is by definition a reification fallacy.
Stop there. Who is saying that this is concrete?
You claimed that it's possible it was real.
Okay, yes. Possible. Concrete would be to assert that it is real.
No. You're claiming it's possible it's concrete.
Possible that it's real is not the same as asserting that it is real. Do you not see the distinction?
I do see the distinction, but you're claiming it's possible that it's concrete.
Yes.
Okay, I'm saying no, it's not possible because that would be
How do you know that?
Because it would be a reification fallacy.
That's a circular argument. You're saying that it's a reification because yes, it is, sir. Okay, so in all right, let's talk about this. Are you aware of Heisenberg's equation?
Yes.
Sorry, Schrodinger's equation. That's the one I want.
Yes.
Okay. Does it involve imaginary numbers?
Do what?
Does it involve imaginary numbers?
Yeah.
Okay. Is it accurate?
Good question. I mean, it's somewhat accurate description. Yeah.
Yeah. Okay. So if we have a theory that exists in that provides good accord with observational evidence, that hypothesis is considered valid, isn't it?
The equation isn't a hypothesis.
Yes, it is. The hypothesis is that this equation well describes quantum systems, right?
You used the equation in the hypothesis, and then you're trying to claim the equation is the hypothesis. Which one is it?
Yes, you're drawing a semantic distinction with no difference.
No, there's a major difference. The equation itself is merely a mathematical description, bro.
Yes. Okay. So the hypothesis is that this mathematical description well matches observable reality. Correct?
Sometimes.
Okay. Point to me a time where it doesn't.
I think it's non-relativistic. So, like,
well, okay, but you've claimed that relativity is gibberish, right? You've claimed
well,
that
I'm actually.
So,
wait.
that can't be your criticism of it, right?
Okay, but wait. I'm saying, like, within your paradigm, you're claiming that it's accurate and you believe in relativity, but it's non-relativistic.
Well, show me the observations where it doesn't accord with reality. What I'm asking, I don't care about its theoretical
I'll tell you.
limitation. What I want is where it doesn't work.
Okay, anything close to the speed of light, quote unquote, and from my understanding, it doesn't even include quote unquote gravity. Again, I am critiquing within your paradigm.
Yes, it doesn't involve gravity, but has that stopped it from? So it isn't a complete description. That's fine, but that doesn't mean that it doesn't have value, right?
So you moved the goalpost.
Okay, do you have a better hypothesis? So we have a hypothesis that this. We have a hypothesis that this mathematical.
Yeah, but it's not the truth, is it? Your hypothesis. It's not the truth, though, is it, Tony? PhD, lying dog. It's not a truth, though, is it? Your hypothesis.
Moderator.
Okay, dude, we don't need you to jump in and call them names and stuff, man. But dude, can we, like, how has this happened, right? Like, you've totally shifted the burden, because I think you thought maybe I would just be unfamiliar with it or something. But, like, in your own paradigm, you're contradicting yourself. It's non-relativistic. It doesn't include gravity. I think it also doesn't work with your beloved Planck scale that you talked about for 30 minutes earlier. So my point simply being, it's a mathematical description that is useful at times, but sometimes it doesn't work. And that's fine, because we know it isn't real. It's just a useful tool. It's a mathematical description. It's intrinsically abstract. If we were to assume, because it's math.
Okay, you're just asserting stuff. You're asserting that mathematics can't well describe reality and ignoring the fact that it very often does well describe reality.
I did not say. I said it can describe reality.
Okay, it can describe reality, and apparently it does describe reality in very many circumstances. Certainly in all of the circumstances that you accept as real, it seems to, and yet you are asserting that that it is impossible that
it's real.
There is an imaginary component to time, or that this can have any physical significance. And I don't see how you can know that.
You're conflating the description of reality with reality itself.
No. So I'm not saying it's real. I'm saying I don't know. You're saying that you know it isn't real, and I'm asking how.
It fundamentally can't be real by definition because it's abstract.
No, an abstract formulation can be accurate to reality.
It can accurately describe reality. And let me actually add a qualifier here. I'm critiquing within your materialistic parameters of quote unquote science, or within material science, because you're making a materialistic naturalistic claim about it, because this is important because I don't want to get clipped later or taken out of context. When I say, like, abstract can't be real, I mean logic is real, right? What I'm saying is that you're applying this to physical reality.
Logic is
I know that's my point.
So, and it isn't real.
I trapped him. So now if something's abstract, it can't be real?
No. That's not the comment. That's not the context in which I was offering this comment. So it is possible for there to exist an axis of time that is orthogonal to that which we experience. It is possible for elements along that axis to apply rotations in the same way that the complex plane does. None of this is physically impossible. And you are asserting that it isn't, that it is physically possible. You are asserting that you know a priori that can't be true, right? No, I'm not. I don't care about the mathematics anymore. You are now asserting that you know that there is no dimension orthogonal, no dimension of time orthogonal to what we can see, and and you know that if such a orthogonal dimension were to exist, it wouldn't have the rotation properties of the complex plane. You know both of those things to be true. How?
Okay, so please don't interrupt me here. Like you just breezed right past the fact that you brought up Schrodinger's equation, and it was a perfect example of how you seem to like have a break. Your logic breaks down, right, when you really think about it, because you were treating Schrodinger's equation, and this is the answer to your question as well. You were treating Schrodinger's equation as if it's like a real physical thing, right? And then the way that you were trying to defend that is by bringing up its accuracy, right? So you are conflating mathematical accuracy with physical reality or viability, but they're fundamentally different. So you are conflating the mathematical description of reality with reality itself. Same here, right? Like you're saying an imaginary unit, for example, can be a real physical thing.
Okay. I've abandoned the mathematical formalism. It's over there. We're no longer talking about mathematical formalism or mathematical descriptions. I am asking, as a matter of physical knowledge, do you know that there is not a dimension of time orthogonal to that which we can see?
Time is an abstract.
It's a yes or no question, sir. Is there a dimension of time orthogonal to that which we can see? And if there isn't, how do you know?
No, because that requires physical properties, which would require the misplaced concreteness of an abstraction.
We're not talking about abstractions at all. We're talking about whether or not time has a dimension that you can't perceive. Do you know that time doesn't have a dimension that you can't perceive?
Time is an abstraction to have a dimension
Do you know
to what?
It's a yes or no question. Yes or no?
I answered it already.
Do you know that time? But you keep on making a circular argument. You keep on saying that would be an abstraction. No, I'm talking about physical time.
That's not circular, man. Like, demonstrate the circle.
Yes, it is. And yes, it is. And multiple people in the stream have pointed it out to you.
Cool. But, what's the circle?
You know, it's a matter of public record now that you really suck at logic.
What's the circle?
Okay.
What's the circle?
The circle is that it can't be real because it would be a reification. And it's a reification because it... But you keep on making a circular argument. You keep on saying that would be an abstraction. No, I'm talking about physical time.
That's not circular, man. Like, demonstrate the circle.
Yes, it is. And yes, it is. And multiple people in the stream have pointed it out to you.
Cool. But, what's the circle?
You know, it's a matter of public record now that you really suck at logic.
What's the circle?
Okay.
What's the circle?
The circle is that it can't be real because it would be a reification. And it's a reification because it isn't real. You don't know that it isn't real because your argument is that can't happen because if it did, it would be a reification of a theoretical model. Well, so if I come up with a theoretical model of God, now God can't exist because they're a reification of my model.
No. And this is a straw man.
Well, then your logic falls apart in reductio ad absurdum.
No. Because no, this was a straw man, right? Because what I'm saying is that time being an abstraction, and when pressed to define it as a real physical thing,
it's a physically measurable thing.
Physically measuring something right? Which is a concept. Doesn't mean that
No,
what you
physically measuring something is not a concept. If I wander up and punch you in the face, that is not a concept.
Physical measurement's not a concept. What I'm saying is what you're claiming to measure, right, is. Because in reality, what we're measuring is change. Like if I give you an example, an atomic clock, do you know how atomic clocks work? I'm sure you do.
Obviously.
Okay, they're just measuring change in the system.
Yes. Okay.
Okay,
Fine.
so we're measuring physical.
Are you claiming that change is an abstract concept?
Yeah, the change is an abstract description.
Okay.
What we're observing.
So everything is abstract. There's no reality.
No, the constituent physical parts are physical reality.
You've completely divorced yourself from reality. Is that what I'm hearing?
No, let me give you let me explain this. It's very simple, man. Like an atomic clock, there are different versions of atomic clocks.
But the arguments you're presenting are incoherent.
No, there are different types of atomic clocks. Do we agree?
Yes.
Okay. And so they are quote unquote measuring time by measuring the change in the system, but the actual things, like cesium atoms, vibrational decay rate or whatever. And
there's no decay rate in cesium atoms. What are they measuring?
Like basically how fast they vibrate per second. So, and they call a second like 9 million clicks or whatever. Yes.
So that they're measuring transitions of excited electrons, right? The number of transitions that occur.
Sure. I mean, they kind of.
That's exactly what he said. That's exactly what he said.
No, it isn't exactly what he said.
Yes, it is. You are now squabbling. You're squabbling, sir. Shut up and let him speak.
Yes, I'm now showing that my opponent has no understanding of the physical discussion that he's entered into.
That's not true. I said that they measure based on vibrations or oscillations.
Yeah,
and something
you said
like
they measured based on decay, and there's no decay involved, is there, sir?
I quickly corrected the record and explained that with cesium atomic clocks, it's based on the oscillations. It's like 9 billion of them equate to a second or whatever. So it's based on, yes, the transitional state of the cesium. The quote-unquote cesium atoms.
Okay,
and it's
oscillations of what?
It's actually the microwaves in relation to the cesium atoms.
What are you even talking about?
It's oscillations of microwave radiation in relation to the transitions of cesium atoms, and 9 billion or whatever it is.
Transitions of electrons, right?
Sure. I mean,
why has the term electrons not entered this discussion?
Well, I said sure. Like I don't have to say electrons to define how it works, though, because it's based on the transitional state
between electron shells. It's counting transitions between electron cells. You're talking in vague terms about oscillations. That doesn't help me. Oscillations of what?
It's not. No, it doesn't count the electron.
It's transitions between electron shells that are being counted, right?
Oh, what actually is being counted is that what they're doing is they're causing the quote unquote cesium atoms to be in two different states, and then they're filtering up.
Around cesium atoms. Do you
Well, because I don't want to
believe in the atomic theory of matter?
No, but let's not get into that. So I'm like in good faith. I'm interacting with it, right? The phenomenon is real. The model's reified, but it doesn't matter. So what they do is they use microwave radiation to cause to create like basically different states of these atoms, quote unquote, so that they can filter them out, right? So the atoms pass through like a chamber where they're exposed to microwaves. Right. And then they can adjust that microwave frequency. They do that based on the desired state. And they quantify a second as like 9 billion, 123 million, whatever it is. I don't remember it. Right. And then so whenever
an electron between shells.
When the frequency matches
like the counted, right?
Sure.
Okay. So it would be a lot better for you if you actually bothered to study some science rather than disagreeing with it without the first clue of how clocks work. This is very
I didn't
basic
disagree
stuff.
with anything. This was all super pedantic diversion. My point was, and you derailed my point, which is that there are different types of atomic clocks, and you agreed, right? So we have like, I don't remember what all they are. You have like cesium atomic clocks. You have like, I think, hydrogen, rubidium, or something like that. I don't know, but there are different types. Okay, so my point is, right, that those clocks, they're measuring the change, just to say vaguely, right? They're measuring the change in the system. And what is actually changing is different in each one of those clocks, but they're all supposedly measuring time. So what that shows you is that what's actually physically I'm almost done. What's actually physically changing, right, is not time.
That is incoherent gibberish. But let's step back to one point before your non sequitur. When you say that they're measuring different things, they're all measuring electron transitions, aren't they?
Yes, to an extent.
Okay,
Yeah.
so they're all,
as far as I know, I don't
they're
remember
all
how they all
measuring
work.
electron transitions. It's just electron transitions in different atomic nuclei. Well, atoms. Sorry.
I think so. Yeah, I don't know if there's an exception. I don't remember what all kinds there are. Like there's some type of lattice structure clock or something too, right? But I don't know. Like, is
Yes,
that?
but that wouldn't be atomic. That's because
I thought that was a type
in
of
order for there
atomic.
to be a lattice, there would have to be a molecule. And they're moving towards nuclear clocks at the moment. They've made some anyway. So they're counting the number of times these electron transitions in excited atoms are occurring. Fine, and you're saying that isn't time.
Correct. Because what we're actually measuring is a physical change, right? And what we say that it takes time for those physical changes to happen, but what we're literally measuring, right, is like the oscillation, the amount of time something moves back and forth, and we've decided to call one of them, right, like our 9 billion of them, a second. And so my point is now if I turn over to another clock, so that's one type, that's an atomic clock. We're going to use atoms, whatever types of atomic clocks we want to use. Okay, they're going to use the transitional component of electrons. Cool, sounds good. Whatever, it's the oscillation rate. It basically vibrates. In really simple terms, instead of trying to lose people, it's pretty simple. It just vibrates and then they count it. That's how it works. Now, if we look at another clock,
hard word. Is it shorter than vibrations or is it not?
Oh, it's an easier concept. Instead of diving so far into the atomic model that I try to stay away from, I just explain that in very simple terms and yet accurate terms, right? That it oscillates.
You haven't been accurate at all until you looked up until you Googled it. You were prattling.
What? I did a whole stream on this. I didn't Google anything. I know that it's based on the oscillations and it's relative to the microwave radiation, and then they tune it with the microwaves.
If you knew what these terms meant, an oscillation is an extremely specific thing. An oscillation is something where it occupies the intermediate states. That's an oscillation. So a spring oscillating. The position of the weight on the spring occupies the intermediate state. The reason that is inaccurate when you're talking about electron shells should be entirely self-evident. The electrons don't occupy intermediate states. They transition from one state to the other.
Sure.
Whatever, they claim there's a natural resonance of the atom, right? Meaning it oscillates. They use microwave radiation to try to hone that in and keep it at the natural state because they actually shift so that they can keep it at the proper like oscillation rate so they can then quantify
what has this got to do with the existence or otherwise of a dimension orthogonal to the one we can see?
Exactly. This is what I'm trying to explain, bro.
How is it not possible? How is it not?
I don't think you're listening, man.
How is it not possible for the electron to be transitioning along a dimension orthogonal to the one that we see and then reappearing in the shell below?
There you go. You made
How
my
is that
point.
impossible?
You've conflated the electron itself with time, right? And this is
No.
the issue. Yeah, yes.
No, I
Or
haven't.
you're saying where the electron goes. So you're just reifying the dimensionality of
No.
what's in contention. Yes.
No, sir, you don't just get to assert stuff and then say that's what happened. I did
Do you
not
agree
say
what's in
that.
contention is that it can't be okay? Your question is, I don't know if I'm going to
How?
phrase it exactly right. Can time exist orthogonal to what we can perceive?
No, yes. Well, let's adopt that. Can there be a dimension of time? Can there be a dimension of time orthogonal to what we can perceive?
Okay. Do you remember what my answer was to that?
Yes, and it's incoherent gibberish and remains incoherent gibberish. Your answer was no, because that would be a reification of an abstraction.
I even specified it.
We're not talking about the abstraction here. We're talking about the physical reality. Whether or not the physical reality agrees with a particular model is for the moment irrelevant. What we're
I'm saying
talking
time
about
isn't physical.
Yes, it is.
Prove it.
It exists in physics. It's measurable.
What?
Time is measurable,
Definition of
therefore it's physical.
Not the first definition of something.
Okay, so yes, but I'm using the scientific definition of physical.
Yeah, they're both scientific definitions.
Yes, you're a biochemist, not a physicist. So when I use the
Doesn't
term
matter.
physical,
Dictionary.com doesn't lie.
yes, madam, when I use the term physical, I mean of or having to do with physics, measurable.
You need to make that clear.
Okay, well, given that we're talking about physics, I kind of thought that the meaning of the term physical might be obvious, but since it isn't, let me spell it out. There are multiple, the term physical is polysemous. It can mean something that is material, tangible, touchable, but it can also mean something that is measurable or something that is in physics, in the field of study of physics. Time is physical. Time is an element of physics, and time is measurable.
Can I help you out here, man? Like, even in your own paradigm, right? There is no time field or particle of time, right? Clocks don't detect time itself. They measure change, like oscillation, vibrations, decays, right? So we're not without change. Be no way to even talk about time passing. It's just an abstract.
Thank you for your non sequitur. Time is not abstract.
That non sequitur.
We're counting things that actually occur in reality.
Yes, I agree. I agree. I agree.
It occurs in reality? Okay. Yeah. Then, if we are measuring the rate at which that change occurs, we are measuring time. We are quantifying the continuum in which these events are embedded.
Continuum. Okay, real fast. You said we're measuring the rate. Rate is math. So we're measuring the math. And this is the point I'm making. What we're measuring is something that's real and physical, moving at a specific rate or changing at a specific rate. So it isn't that time is physical.
Rate is not maths.
What?
Rate is not maths.
Okay, what is rate, bro?
Rate is the change in something per second, per unit time.
Okay, per, right, denotes
and you're claiming that time doesn't exist, therefore rates don't exist. Therefore light doesn't exist. This is idiotic quibbling. Time exists. And your claim that it doesn't is fatuous nonsense.
Rate is quantity over whatever your reference is. It's a fraction. Per denotes a fraction.
In this context, it's per unit time.
Okay, whatever your reference is. So, and it is a fraction, which is math. So this is the issue, and I don't understand how you don't get it. I don't understand how you don't get it, man. I don't understand how you don't get it.
I I can measure the inclination of an object without using fractions.
Okay, but your definition was the rate.
No. Are all numbers fractions? Okay, so 4/2, is that a fraction?
Yes.
Yeah, prior to being solved.
Okay, but it's an integer too, right?
Yeah, man. Look, dude, can we please zoom out some, because I want to wrap this up.
All numbers are fractions.
Yeah, can
right?
we wrap this up, please? Is a piece of chocolate a fraction? A little piece of chocolate, that's a fraction.
I mean, Tony, I disagree with you, man, but it's cool, right? I mean, I think you're just fundamentally wrong. Do you want to like give your final bit about this point?
No,
Because I just
I'll
want
go
other people
after
to.
you, because the last time you fucking bushwhacked me with a bunch of bullshit and straw men. So why don't you fucking go first, and this time I'll finish up.
Okay, cool. Because you mean the last time you got MJ from the free throw line, and it was tough to handle. Okay, so my point is pretty simple, right? Is before we even get to this like mystical, magical transition of time to imaginary time, like the SpongeBob meet imagination. Before we even get to that point, we were just discussing how time itself, right, is actually not physical, right? It is a measurement or quantification of change, right? And passing and progression does seem to be a real thing, but it's an abstract thing. It's not a real physical thing. And so every example that was pointed to or could ever be pointed to supposedly measure time as a real physical entity, right? It's always going to be something else that's physical that's changing, and then we are simply measuring the rate at which that change occurs. So, it isn't anything other than an abstract, because math is intrinsically abstract. If we then apply concreteness to that, as if it was like the real physical thing that we were measuring, then that would be a reification fallacy, because it isn't. And this is where you saw him when he brought up the Schrodinger equation. He very quickly conflated the description of reality with reality itself, and then seemed to conflate or equate the idea of its accuracy mathematically with its like legitimate existence in reality. These are all just fundamentally fallacious reification fallacies. So that's my point, is that even at its base level, in modern times, like in quote unquote science, the way that time is utilized is actually a reification fallacy. Certainly the way that Tony is using it. If we then jump all the way out of here and we say, okay, so could time exist orthogonal to what we perceive? You're still just treating it as if it is real, because in order for it to be orthogonal or have dimensionality requires the presupposition of physicality, which we know is fundamentally impossible because it is strictly abstract. So the imaginary unit is this way that, and Hawking actually points out, like, dude, this is like the best I could come up with, and it took him, like, it was like his life's work almost, and it was under his own admission. He was like, this is basically my attempt to give any type of possibility that doesn't require a supernatural creator, and this is the best I can come up with. He never claimed that this was true. But the point is that he had to then just kind of say, well, at the beginning of the universe, time wasn't the same. It existed differently. And I'm not really sure how, but it just would have to be outside of what we use time as now. And so I'm going to refer to it as a imaginary time, right? And so my point here in conclusion is that not only is math intrinsically abstract, but an imaginary unit is an even more egregious form of the abstract. There is no actual, observable evidence for it, nor is there even like an intelligible definition of what it is. And so to then say that it could be real would require you attribute concreteness to the abstract that is the imaginary unit of time. So it can't exist. It's fundamentally fallacious and impossible. That's the point.
Okay, so Witsit is claiming to know that something is possible, and he has no observational evidence to support his assertion. Whether or not something accords with an abstract model is irrelevant to its physical existence or otherwise. And people can make hypothetical suggestions about what might have happened. They are not reifying it until they say that is definitely true. But a mathematical model that reliably gives results in agreement with observation is by definition valid, right? It has not yet been falsified. And what Witsit is claiming is that he is preemptively falsifying these hypotheses without any observational evidence. And he has no logical
asked him, and he went, but we were going in and we couldn't really talk about it.
What were you talking about? Yeah, somebody.
That was my bad. I think I hopped my bad, guys. My bad with this stupid Discord. I apologize.
No problem, SC Montreal. Always good to see you, by the way. And I hope you're doing well. But so nobody is claiming that Hawking's boundaryless universe hypothesis is true. It's just a possibility. Similarly, Witsit claims that it's the best Hawking could come up with. There are literally dozens, maybe even hundreds, of alternative hypotheses for the initial moments of the universe that are completely distinct from Hawking's, which are equally consistent with the observational evidence. Until we get more observational evidence, we won't be able to rule in or rule out any of them. And Witsit's attempt to justify ruling them out on the basis of an unfounded extrapolation from the very brief period in time that we can directly observe is scientifically fraught and not a valid syllogism.
All right, man. Room is open.
All right, sweet. I want to talk about fuzzy logic and how no one ever, in application of fuzzy logic, decides to put aside the law of excluded middle, because that would be ridiculous.
But if someone is using actual correct logic and you're just calling it fuzzy logic to dismiss it, isn't the fallacy falling back on you then?
I'm not using fuzzy logic. Someone invoked fuzzy logic, and they said that, let me get you the exact quote.
Direct my question.
Let me finish. In fuzzy logic, logicians say the law of excluded middle don't apply.